Hello, everybody. I'm glad to see you on our Codeberry Club community stream. And today we are going to talk about performance. We are going to continue our series of events related to performance of Java applications. Don't forget to follow us in Telegram and on the YouTube. And I'm going to give microphone to Vadim, who will be speaker today. Vadim.
Hi everyone, and today I would like to share you the series of performance battle, and I'd like to provide you the news information regarding the Micronaut and the Micronaut Reactive and Reactive as native as well. So let's move on. What we'll have today on the session, and firstly I'll introduce myself and introduce the service we are going to test, the main business idea, and which presets I currently have. A little bit of presets of Micronaut Reactive and Reactive as native. Then we'll compare it with Spring and Quarkus, my previous researches, and just sum up it. So, who am I? Here we'll take a look briefly on my experience and domains, technical stack, and you can find me in my social networks. I am a chief software engineer at EPAM Systems, and my key business domains, finances, human resources, car founding, and healthcare. I'm a T-shaped person, and mostly I'm working with JVM stack area regarding the Java and Kotlin, and for sure I'm mostly working with the Spring family frameworks, and I really enjoying with using of GIB and of and I'm familiar with Kubernetes, GitHub, GitLab CI, JMeter, and Kotlin performance testing, and Google Cloud Development Architect. And you can find here my stats on GitHub. You can fork a clone and start them, whatever you want. And you can find me on LinkedIn and GitHub or on Instagram. Okay. Introduction. In this section, we will briefly take a look on Micronaut and compare the Spring Quarkus. And the Micronaut says that it's faster and less expensive due to the fact of lower resources consumption and better serialization during the build time. Trust but verify, and I'm going to verify it. I will test the most efficient approach of Spring and Quarkus to compare it, and I would like to test the reactive approach using reactor HTTP and data R2BC with R2BC pool and Vertex PG client. Same to Quarkus, yeah. And I hope you're familiar with my previous performance results regarding the Spring Web as native, Spring Reactive as native, and Quarkus Reactive as native as well. If not, you could easily find them on my GitHub. I'll provide you QR code on the next slides. So this article is not about the Micronaut internal architecture and design, its paradigm, and the solutions that Micronaut team brings to life. This article is about performance. I will not dive deeper into the Micronaut Reactive stack and the business description of my application. You could always read it on your own in my previous researches and in the documentations as well. And today I'll check the performance of native executable, including in Docker solutions, and the default one, including in D solution as well. Here you can find the comparison of Micronaut and Quarkus and Spring, but you can find that the Quarkus and Spring versions and Micronaut as well are outdated, and this is a hello world checks using benchmark, and mm, this is the results of April 2020. I've asked Grammy Rusher why did he uh, have no any comparison after this date, and he's postponed my messages in LinkedIn, but he answers me a few days ago and said that, we will have the fourth major version soon for about several months. Um, and seems like they are going to compare them later. But to me, it's really outdated comparison, and I'd like to understand. Does the Micronaut is so stable and such a great uh, perf- great framework as we can find it on this result table. And um, uh, but firstly, I'd like to dive in my application logic and use cases and database structure we are going to test. So the application is typical transportation service, and it mostly loaded from 8 a.m. up to midnight. It's for about a 60 per day load, or 120 hours load per week, and which presets I have. I disabled all applications levels caches to get clear performance metrics of this server as it is, as the database and application are running in the same network to avoid net lags and penalties. The fetching strategy is eager, but it's most relevant for the previous researches. And I did not have database migration tools such as Flyware or Liquidbase, not to have the lags on the boot up um, stage, and all the base structures had been already prepared and pre-filled with fake data. And the load testing tool, I choose Gatlin. I really enjoy this tool. And the versions of languages, frameworks, libraries, and databases are the latest LTS at the moment of testing. So this application is about the Belarus and the six major cities, and we will just imagine that we have 20 points for revenue debugging, and I assume that every point has about 100 transfers, and the target audience is about 200,000 users. And which use cases I have? It's typical just choosing the country, city, origin, and destination, the date of transfer. I'd like to see available transfers for these presets. I'd like to book transfer, cancel transfer, to see all my transfers, update them, complete, look at my profile or update. So it's to my mind, and to be honest, it's a basic use cases that transportation service could have. Database structure pretty simple. We have one country, six cities, like 120 locations, 12,000 transfers, 200 users, and about half a million users transfers. And this is the scheme. And the database size in Docker, 160 megabytes. What about the Micronaut Reactive? We will take a look on basic configuration, on test results, and Docker image analysis. I've already mentioned, I decided to check all possible types of launching the application, such as jar and Docker, native executable, and in Docker native solutions as well. In Micronaut, we have several ways of building a Docker image. It's jar and Docker, using it in JVM, JVM native executable in Docker, native executable, CRAC, and AOT optimized Docker image. And this is my typical preset of my working MacBook. you can find that I'm on the Intel Core i7, and the RAM is about 32 gigabytes, and I have 4 cores. GTK 17 JCJ1 Gradle 801. Yeah, I know it's currently is 8 and 1 version, and they have great improvements for caching performance, and Micronaut 385, Gatlin 392, Dive and Gripe to dive the Docker images and griping them for different vulnerabilities. And this is the application YAML. We can find that it's pretty simple to understand, and it's enough to boot up your application. So what about the test results? We can find that jar boot time is for about 70 seconds, and but when you're using the default Docker image, it's about 74 seconds. What about the sizes? The jar is 21 and Jeep distilless 252, and default Docker image, if we are choosing the Micronaut default Docker image, we can find that it's bigger for about 100 megabytes, and we should to understand that storing one service for 100 megabytes, it's okay, but if you have a thousand of these services, you could pay a lot of money for this difference, and for transferring and storing, etc., etc. What about the boot up? Yeah, Micronaut said that they have a great boot up. We can find that a typical jar application are booting up in 1 second, and Jeep Jeep and using distilless-based image for less than 2 seconds, and default Docker image a bit more than 2 seconds. The RPS, the best RPS when we are using typical jar, and we have some penalties using the in Docker solutions. And response time, I'd like to mention, this is a critical and a tricky case, because of I really stress, I'm using a stress testing of the application. Response time on the 95 fifth percentile is 90,000, and saturation point is for about 2,500 units. So RAM consumption, you can find that it's bigger than 4 gigabytes, and but when we use a Docker solution, it's pretty less. Okay, this is what I'm talking about when I'm talking about a non-native solution. When we are going to take a look on the Docker images, we can find that total image using the default Docker image size is 346 megabytes, and when we are using a Jeep based on distilless, pretty less, and potential waste is 0. Here we can find it not such a big number, but we have it, and that's it. And what about the vulnerabilities? When we are talking about the vulnerabilities, we can find that when you're using the default Docker image, we can scan it and find 100 packages, and here there are 79 vulnerabilities, and when we are using Jeep based on distilless, we can find that here 40 vulnerabilities. Micronaut Reactive as native. Pretty similar. We'll take a look at basic configurations, test results, and Docker image analysis. Basic configurations for my test are pretty similar. This is my working MacBook Pro, and a bit. Sorry. Sorry for interrupting. And yeah, um, um, same versions of GTK, garbage collector, and Gradle, Micronaut, Gatland, Dive, and Gripe, and the same application YAML. It's pretty good. I do not have any difference to instantly boot up or build. And now let's take a look on these what we have during the stress testing. The build time pretty bigger, and it's expected, to be honest. And a native executable for about 3 minutes, and uh, pretty bigger for the default native Docker image, and in 10 times, even more than 10 times, we have building time for AOT optimized Docker file native. If I spent such a big time for building the optimized Docker file native, I'm expecting great performance tuning or different optimizations, and we'll take a look at. What about the artifact size? Native executable, 78 megabytes, and the default native Docker image and AOT optimized Docker file are pretty similar. Boot up, 42 milliseconds. Great for the native executable. And in Docker solutions, pretty similar for about 100 milliseconds. And what about the RPS? For native executable, it's 500. And on previous section, when we've tested the jar solutions, we found that it's for about 600. And for in Docker solutions, we have degradation. And response time for about 25,000 for the native executable, and in 2 times higher for the Docker solutions, and saturation point 1,700 in best case. RAM consumptions at max are for about 700. Okay, now what problems I faced? To be honest, it was unexpected for me when I migrated to Gradle 8. Micronaut stopped to build and prepare the artifacts for test. To be honest, when we are using such a major framework, micro framework, it's impossible to believe that they could not prepare using the release candidates for such a great migration from the 7 Gradle version to 8 version. But we had it, and it could lead to the unpredictable loss on the productions. And for me, it's really not clear to understand how does it impossible. And there are a lot of problems with the checksums on netting. For about the 60% of common KOs were related to it. Okay, now what about the AOT optimized Docker image and default Docker image? We will compare them because if you remember, we've spent a lot of time to prepare the AOT optimized Docker image. And total image size, 99 megabytes with weight of 500 kilobytes. And for default Docker image, we have the same numbers. And I do not understand what was going on. with the optimizing. If we have no any optimization, in this case, using the Docker scanning, Docker image scanning, and on the previous section as well, that were related to the performance. But we've spent more than 10 times time seconds more for this. And let's compare the vulnerabilities. 48 vulnerabilities in 90 packages for its optimized Docker image, and absolutely the same numbers for the default Docker image. So, to be honest, it's not clear for me why I should spend more than 5,000 seconds to prepare the optimized Docker image to have literally the same results. And now let's compare the results of Micronaut with compared to Quarkus and Spring. We'll compare jar test results, native test results, and in Docker test results. What about the jar test results? We can find that Micronaut can have a bigger build time, and we have pretty similar to Quarkus artifact size. Yeah, but top time pretty less than previous results, and RAM consumption, a huge difference with the Spring Web, Spring Reactive, Quarkus, no matter, and not such a big results regarding the RPS. So we now can compare what Micronaut said with what we have. Micronaut said that they consumes less resources. Nope. They said that RPS is higher. Nope. But yeah, boot up time pretty less. And now we'll compare same solutions. Gaps in Docker, and we can find that RPS again on the same level as the Spring Web using the reactive approach. We have this almost same results, and RAM consumption less than the previous researches, build time higher, artifact size a bit higher for about 100 megabytes, but it's higher, and boot up time something in the middle between the Spring Reactive and Quarkus. So if we'll compare with the results that Micronaut presented us on their website, the RPS not such a big that they provided. The boot up time using in Docker solution as well, but RAM consumption, yeah, this is a pretty good result. What about the native test results? For native test results, RPS again less than we have in Quarkus or Spring Reactive, and boot up time pretty less, and that's great in comparison with the Spring Web, Spring Reactive, and Quarkus. Artifact size for about 80 megabytes, and it's higher than for Spring Reactive and Quarkus, but less than when we are using serverless API or the Spring Web, non-reactive stack, I mean. And the build time is pretty similar to the Spring Reactive, but bigger than for the Quarkus. And RAM consumption we could say that almost the same, but not we have a bigger RAM consumption. So what about the RPS? Again, we failed it. RAM as well, boot up, great again. So booting up is pretty funny with Micronaut. Okay, and what about the native in Docker? And native in Docker, we can find that boot up are pretty similar for the previous researches. And when we using Spring Reactive or Quarkus, they are on the same level to my mind. And artifact size the same for Spring Reactive, but a bigger and higher for Quarkus than Quarkus have. And build time, something in the middle between the Spring and Quarkus solutions, and less RAM consumption in Docker solution in comparison with Spring Reactive and Quarkus. And RPS even less than when we are using the Spring Wrap. So again, boot up is pretty good for native in Docker solution, RAM consumption as well, but RPS, no. Okay, so let's sum up it and gather everything together. I'd like to share my thoughts regarding the Micronaut and compare it with the reactive solution, Spring and Quarkus. And to be honest, the Micronaut has not so good and clear documentation as Spring and Quarkus have. And for sure, the moment with the migration from Gradle 7 to Gradle 8 was critical for me. And when I'll repeat it again, when such a great and famous framework doesn't support it, it's unbelievable. Yeah, they fixed them really quickly, but cost of failure could be unpredictable. Native solutions have less vulnerabilities in comparing with the non-native solutions, and native in Docker solution doesn't work properly with native checksums. A lot of failures. And to compare it with the Spring Boot 2 and 3 and Quarkus 1 or 3 is totally outdated. Micronaut could not bring the benefits he brought in 2020. So what to bring into production is up to you. But to my mind, the Micronaut was a game changer with their killer features for a long time. But nowadays, when Spring 3 Plus version provides the same native solutions and the Quarkus that supports almost the same, I cannot find any killer features to use Micronaut in production or migrate to Micronaut from Spring or Quarkus nowadays. And there were too much efforts to solve the problems that should be done out of the box. And it's really hard to imagine the business use cases and architecture problems that Micronaut can solve solely. Now I will provide you the QR code for research, and you can dive deeper, and you could clone my sources and check it on your own. Thank you for your time, and I believe that we will see you again later when I will provide the research regarding the vertex. I really have a great feelings regarding this framework. But as I said, trust but verify.
Thank you. Thank you for the research and thank you for the talk. We have one question, but before the question, I'm going to ask my own question. As I can see, you use Mac with Intel processor for as test environment. Did you try to run the tests on Apple processors?
Nope. Nope, to be honest, nope. But if I will migrate my workstation or uh, I'll buy this MacBook on my own, probably I will try to find the time and compare it.
I think it
Andrew?
some interruption
And
in
sorry,
connection.
we lost you. We lost you. Yeah,
Are you hear me?
yeah. Right now, yeah. Let's discuss and what kind of framework Andrew using when we listen him twicely in 2 minutes. I'm enjoying
So,
the community.
let's move to the question. We have a question. Are there any specific use cases where one is better than other? I think the question is related to all of frameworks, probably.
Yeah, I understand.
Uh,
To
what do you
my
think
mind,
about?
to be honest, these frameworks are different, but it's a really tricky case. We should dive in architecture and the business needs of a specific area, and there are no silver bullets in this case. In some cases, Spring could be better. In some cases, even Micronaut could be better. In different situations, Quarkus will have much more killer features regarding these frameworks. And some in different cases, your team has no skills and has no experience in the Micronaut and Quarkus, and but they are really great performers in Spring family frameworks. And in this case, the choose is pretty easy. We will choose Spring because of knowledge transferring and diving into different frameworks. Migration to different frameworks are really very costly.
Thank you. Thank you for the answer. I think it should be interesting if we can get information about some server optimized software like Docker optimized operation systems or just so Linux installed on real hardware, but not for today. Thank you for the talk. Thank you for the research.
Thank you as well.
Thank everybody who.
And we are waiting for a Micronaut 4, as Grammy Research said me, and we'll check it again. I really waiting the release, the major release.
So next time in performance battle number 5, we will talk about new release.
No, I will talk about the vertex, but as a bonus, I believe I will provide you the data regarding the Micronaut 4, because of they said that it will have great performance improvements, and I will check it. I will check it.
Sounds interesting.
Yeah,
So I think that's it for today, and see you next time. And follow us on
yeah.
YouTube and in Telegram. We will share our updates and information about the next.
So stay safe and enjoy your time.
Thank you. Bye.
Bye.